Hi everyone, so welcome to the channel. So in the previous video we have discussed a few problems related to the exercise 3b of straight lines of 1b junior intermediate AP TS and NCERT. Right, let us continue with the remaining problems. Right, question number 5. So what he has given, if the sum of the reciprocals of the intercepts made by a variable straight line on the axis of coordinates is a constant, then prove that the line always passes through a fixed point. Right, now let us consider the variable line. So consider that variable line as x by a plus y by b is equal to 1. So let this is the variable straight line. So what he has mentioned, right? So from this, what is x coordinate? What is x intercept? So here the x intercept is a and y intercept is b. X intercept is a and y intercept is b. Right, now what he said, the sum of the reciprocals of the intercepts. So sum of the reciprocals of the intercepts means, so 1 by a plus 1 by b. Since a and b are intercepts, though the reciprocals is 1 by a and 1 by b, and he is saying their sum. So 1 by a plus 1 by b is a constant. The sum of those reciprocal sum of intercepts is some constant. So let it be some k. So 1 by a plus 1 by b is equal to k is the thing that we got. Right. So this is my equation, and this is the condition that he has given. So 1 by a plus 1 by b is equal to k. So if I rearrange it and write, so I can write it as, so this k, if I transpose to the other side, I can write it as 1 by a. So this I can write as 1 by k times of 1 by a plus 1 by b is equal to 1. Now furthermore arrangement, so 1 by k, if I multiply with this 1, then I can write it as 1 by k by a plus 1 by k by b is equal to 1. So here just we are rearranging them. So 1 by k by a plus 1 by k by b is equal to 1. So let this be equation number 2. If you compare these two equations, equation 1 and 2, so what way can you say? In the place of x I am having 1 by k, in the place of y also I am having 1 by k. So from 1 and 2, what I can say? So x is equal to 1 by k and y is equal to 1 by k. Already he has mentioned this k is a constant, so 1 by k is also a constant. So clearly what I can say, x is equal to 1 by k and y is equal to 1 by k is nothing but the values through which my given line passes. Right. So from this what I can say, the point x comma y is nothing but the point 1 by k comma 1 by k. So this is nothing but a fixed line because k is constant. So 1 by k is a constant, 1 by k is a constant. So clearly, so x comma y is a point 1 by k comma 1 by k. Hence it is a fixed point, right? So this point is fixed. Hence what I can say, then this line always passes through a fixed point. So this line x by a plus y by b is equal to 1 always passes through a fixed point 1 by k comma 1 by k, because when it satisfies this condition. So 1 by a plus 1 by b is equal to k, it always passes through 1 by k comma 1 by k. Right. So this is nothing but the proof. Next, moving on to question number 6. See, line L has intercepts a comma b. Now let us consider this particular black solid lines. So we are having black solid lines now. Let us consider this black solid lines as my x-axis and y-axis. So this is my x-axis and this is my y-axis. Now in this gray color line, I am considering it as my line L. So what is the line L given? That I am representing with this gray color. Okay. Now what he has given, this line L has intercepts a comma b on the axis of the coordinates. That means this length is a, and here to here this length is b. Right. Now next, what he has given, when the axes are rotated through a given angle. Now these dotted red lines, so these are nothing but, so this is nothing but angle of rotation theta. Then this newly formed axis is nothing but x dash, and this is my y dash. So clearly these are nothing but the rotated axis. So both are rotated through an angle theta. So if this angle is theta, then this angle is also theta. This angle is also theta. Now keeping the origin fixed, so it is only rotated through an angle theta. The same line L has intercepts P and Q. Now what he has given here, he is giving that this length is P. So from here to here this length is P, and next he has given that this length is Q. This length is Q, right? So since these lines are meeting my new coordinate axis at these 2 points, so what I am considering, so this particular length is P and this length is Q, right? Now what he is asking you to prove, so 1 by a square plus 1 by b square is equal to 1 by p square plus 1 by q square, right? Now what I am going to do is, so from this figure, so first of all, for the given line equation, so what he said, a comma b are the intercepts, right? So if a comma b are the intercepts, then given line L I can write it as x by a plus y by b is equal to 1. X by a plus y by b is equal to 1. So let this be equation number 1. Now to find out the line equation when coordinates are rotated through an angle theta, right? So if I want to find that, so for that what I am going to do is, so I am going to make some constructions. So let us see this. So from this point I am going to drop a perpendicular. The same way from this point I am going to drop a perpendicular. So if you observe this, so these are nothing but the perpendiculars dropped onto the things. Then what I am going to have, so if you observe carefully, so this is my right angle triangle, and this is one more, so this is one more right angle triangle. So this is one more right angle triangle. So if you observe carefully, so this is one more right angle triangle. Here this angle is theta, here also this angle is theta, and in both the situations, so I know this hypotenuse. So this hypotenuse is P and this hypotenuse is Q. Okay, so no need of considering this hypotenuse, right? So here this angle is theta. Now by considering these two right angle triangles, so we can find out this point which is present on this line as well as this point which is present on the same line L. Okay, so for that what I am going to do is, so first of all I need to consider the values of sin theta and cos theta. So based on that I can write down these points. So this point, so let this point be some A. So let this point be some A, or what we can say, since this is having intercept P, so I am considering this point as some P dash, and I am considering this point as some Q dash. Then clearly what about P dash? So P dash is nothing but a point. So how can I obtain that? This horizontal comma vertical I need to write, right? So this horizontal length is hypotenuse into, since this is adjacent side, so adjacent side means cos theta. So I can write as P into cos theta. So this is x coordinate, and y coordinate will be P into sin theta. P into sin theta. So we got the point P dash. So P dash is nothing but, so first x coordinate, next y coordinate. So that's why x coordinate is nothing but my adjacent side. So P cos theta, P sin theta. The same way I am going to consider the Q dash point. So if I want this Q dash point, so first of all I need to consider this x coordinate, that means this distance I need to find, but it is on the left hand side of origin, no? That means this will be my negative, so this length, so this point will be my negative point. So from this what I can say, minus hypotenuse is q into, so since this is this is opposite side of theta, right? Since it is opposite side of theta, so directly I can consider as minus q sin theta, comma, the same way we are going to get q cos theta. So this length is q cos theta. Okay, we got the points p dash and q dash. If you observe the figure, where p dash and q dash are lying, so p dash and q dash are lying on the line L, right? That means they need to satisfy my given line equation. Okay, so for that what I need to do, so I need to substitute the values. From that what I am going to get, so in equation number 1 I am going to substitute this one as well as this one. So from that what I am going to get, so p cos theta plus by a plus p sin theta by b is equal to 1. Now since it contains p in the numerator, so if I take common p and transpose to that side, then I can write as cos theta by a plus sin theta by b is equal to 1 by p. So let this be equation number 2. The same way this point also satisfies this line equation, right? So by substituting this point, second point in line equation number 1, then what I am going to have, minus q sin theta by a plus q cos theta by b is equal to 1. Now the same thing if I do transposing, taking common q and transposing, I can write it as minus sin theta by a plus cos theta by b is equal to 1 by q. Let this be equation number 3. Now what I am going to do is I am going to square equation 2 and equation 3 on both sides and then add. That means equation 2 whole square plus equation 3 whole square. So squaring and adding. So on squaring what I am going to get, so this becomes cos square theta by a square plus sin square theta by b square plus 2 cos theta sin theta by ab. Here also the same thing. So this I can write it as cos square theta by a square plus sin square theta by b square plus 2 sin theta cos theta by ab plus, so this is nothing but the first term expansion. The same way when I expand this, what I am going to get, sin square theta by a square plus cos square theta by b square minus 2 sin theta cos theta by ab, because since we have minus here, so because of that we get minus 2ab, which is equal to 1 by p square plus 1 by q square. Now since this is minus 2 sin theta cos theta by ab plus 2 sin theta by cos theta ab will get cancelled. Now this is nothing but cos square theta by a square plus sin square theta by a square. Since LCM is same, cos square theta plus sin square theta is 1. So this becomes 1 by a square plus here sin square theta by b square cos square theta by b square. B square is the LCM, so sin square theta plus cos square theta is 1. So 1 by a square plus 1 by b square is equal to 1 by p square plus 1 by q square, right? So likewise we can prove this particular equation. Okay, so he asked you to prove the same thing. So 1 by a square plus 1 by b square is equal to 1 by p square plus 1 by q square. So if you are able to do these simple things, so then you can prove this particular equation. Okay, next moving on to one more question, question number 7. So transform the equation x by a plus y by b is equal to 1 into normal form where a is greater than 0 and b is greater than 0. If the perpendicular distance of the straight line from the origin is p, then deduce 1 by p square is equal to 1 by a square plus 1 by b square. Now let us see this. So what he has given, x by a plus y by b is equal to 1. So first of all we are going to convert this into the standard form of line equation. So we can write it as bx plus ay by ab. So how this is obtained? By taking the LCM. So from this, what I can write it as bx plus ay is equal to ab. Right? Since a is greater than 0, b is greater than 0 given, that means a into b is also positive. That means it is taken as bx plus ay is equal to ab. Now directly what I can do? So I can directly convert it into normal form, because on right hand side we have positive term. So directly what I should do first? Divide with the square root of x square coefficient and y square coefficient. So from this, what is x coefficient here? B. Y coefficient is a. So divide by square root of b square plus a square on both sides. So when I divide with b square plus a square under square root on both sides, then what I am going to have? B by square root of b square plus a square into x plus a by square root of b square plus a square into y is equal to ab by square root of b square plus a square. Right? Now if I consider this as x into cos alpha plus y into sin alpha is equal to, this is p. Now from this, clearly what I can say? So p is equal to ab by square root of a square plus b square. And what about alpha? What about alpha? So here this is cos alpha and this is sin alpha. So from this, tan alpha is equal to sin alpha by cos alpha, no? So this can be written as a by b. So from this, alpha is equal to tan inverse of a by b. So we have written the things in normal form. Now what he is telling? The perpendicular distance of the straight line from the origin is p. That means he has considered this perpendicular distance as p. So p is equal to ab by square root of a square plus b square. Hence we need to deduce this. So for that, what I am going to do? I am going to reciprocate this. So 1 by p is equal to square root of a square plus b square by ab. Next I am going to square it on both sides. Then what I am going to have? So 1 by p square is equal to square and square root gets cancelled. Then I am going to have a square plus b square by a square b square. Now since in the numerator we are having two terms, so we can split the terms. I can write as a square by a square b square plus b square by a square b square. So whenever you are having two or more terms, we can split them and divide, the denominator will be divided, right? So a square gets cancelled. Here b square gets cancelled. So finally I can write it as 1 by p square is equal to, so writing 1 by a square plus 1 by b square. So this is the thing he has asked you to prove. So we have proved it, right?